Hi guys, today we're going to make a review of the conversions from mole to grams and molecules. Why? Because our next topic, the next topic we're going to see is called stoichiometry, and stoichiometry takes these conversions in hand. So if you don't know how to make this yet, it's the time to learn, and if you yet don't understand what the examples I'm going to put, just send me a text and we can make a video call or a conference by Zoom as you guys wish. Alright, so we're going to start on, I'm going to put you the first example. And on the first example, we're going to convert 11.5 grams of ethanol. And we're going to convert it to moles. Alright, I'm pretty sure you remember this. In order for us to convert, we're going to put 11.5 grams times grams down because I want to eliminate gram and moles. Remember that 1 mole is equal to the formula mass, meaning that's the weight of this compound using the periodic table. So 1 mole has how many grams? We're going to figure that out. So we have carbon, we have 2 carbons. Hydrogen, we have 5 plus 1, we have 6 hydrogens. And we have oxygen, we only have 1 oxygen. So carbon is 2 times 12, hydrogen is 6 times 1.01, and oxygen is times 16. Alright, once we have that, we add all this together, and we're going to get an answer of 46.1 grams of ethanol. So right now, I just put my 46.1 grams here, and I divide 11.5 divided in 46.1, and it's going to give me my answer, 0.249 moles of C2H5OH. And that's it for the conversions from grams to moles. It's really simple, and on this next example we're going to use Avogadro's constant. I don't know if you remember Avogadro's constant, which is 6.2 times 10 to the 23rd power. And Avogadro's constant states that 1 mole is equal to a given number of molecules, which is the constant he's given us. So we're going to make an example using Avogadro's constant. Alright, so in the second example, we are going to convert 1.20 times 10 to a 25th power of NH3, 2 moles. Alright, so we need to convert, I skipped the word here, it's molecules. We have 1.20 times 10 to the 25th molecules of ammonium, and we're trying to convert that to moles. So we're going to apply Avogadro's constant because we're using molecules. So I have 1.20 times 10 to the 25th molecules. I'm going to put molec and molec. Alright, so in here, we know that 1 mole is equal to the Avogadro's constant, which is the number of molecules. So I just need to place Avogadro's constant, which is 6.02 times 10 to the 23rd power. You divide that using your scientific calculators, and you're going to get an answer of 19.9 moles of ammonium. If the exercise doesn't stop there, and it tells you to go on and to convert to grams, we continue this procedure. We have 19.9 moles, and we're going to convert it to grams. We have moles down, and we have gram on the top. And of course, 1 mole is equal to the formula mass, so 1 mole goes down. And I'm going to find how much does ammonia weigh. So I have nitrogen. Nitrogen, I only have 1, and I have hydrogen. Hydrogen has 3. Nitrogen weighs 14, and hydrogen 0.01. So the weight of ammonia is 17 grams. So now you multiply 19.9 times 17, and that's gonna give you a total of 338 grams of NH3, and this is your final answer. All right, this is conversions. I'm gonna make one more example so it's clear and so that everybody handles this topic. And on Friday, well, I'm gonna upload a few exercises, maybe just 4 or 5, so that you can just practice, and next week we start with stoichiometry. All right, third and last example. We have 0.638 moles of barium cyanide, and we're going to convert it to grams. All right, so we have 0.638 moles times mole and gram on the top, because I want to convert to grams. Which one's going to carry the one? The moles, because 1 mole is equal to the weight. So 1 mole has how many grams? We're just going to find that out. Barium only has 1. Carbon has 2. And nitrogen has 2. Why? Because this 2 is going to affect the carbon, and this 2 is also going to affect the nitrogen. So carbon I know is 12, nitrogen I know is 14, and barium is 137.3. All right, so plug all that in your calculators, and we're going to have 137.3 plus 24 plus 28, and we're going to have 189.3, which is the addition of this, all right? So now with that 189.3, we're going to multiply times the moles we had, which is 638, and we are given an answer of 120.7 grams of barium cyanide. And that's it. Simple as that is the conversions. But this topic you need to understand, because stoichiometry takes this as part of the procedure, all right? So if you don't know this, please just send me a message and I'll gladly explain it to you again. And I hope you understand, guys.